I value the fact that I think of myself as a natural skeptic. Any idea, even the ideas that I like, I look at and think, can that be right? It's probably wrong, and it's the way that I approach ideas, and so I believe that this is going to be the next step in abstraction in terms of programming. But I don't think that we're there yet, and I think that a lot of the problems that you're talking about are similar to things that we've seen before, but I have more belief that this time this might work.
Yeah, I think so too. I think it's really easy, as a sort of a grumpy old person to look at the sort of the flaws in the current thing and say, oh, well, this is never going to work. But actually, a lot of those are fixable, like the bias towards verbosity, that's
Yeah,
clearly fixable. And I'm just thinking again about the sort of, the future past the immediate future, which is so hard to visualize. But I wonder whether actually, the sort of, I think the dream would be that kind of multimodal programming, wouldn't it? Like a really fluent multimodal programming where you would say, this bit, it feels most natural to me to express it as a bunch of boxes. So I'm going to do that. This bit I want to express in natural language. So I've got, I've embedded my prompt into source control. This bit, actually, you know what? The variables in the math, I just want to do it old school and that's going to be most
yeah,
effective.
yeah.
And at the moment, we really have to kind of choose.
I think there's one of the difficulties is it turns out that text and programming languages are quite good at being able to precisely represent ideas. Actually, in many ways, much better than human languages are,
Mm,
which tend to lack precision. That precision, they tend to be, more variable, more open to nuance and interpretation, and all of those kinds of things. And I think that two level idea is probably going to be part of the future and an interesting one,
mm,
and maybe further, pull the division between the kinds of programmers that are writing things, to solve human needs, and the kind of programmers that are writing things to make computers work better. I
mm.
want, we used to call them system programmers in the old days, but I haven't heard that term for a long time. But people writing operating systems and device drivers and things like that, I'm not sure how helpful AI is going to be in doing that for quite a while. All those kinds of trading systems that I was writing, the ultra high performance things, I'm not sure that's where it plays. But if you're writing a nice little mobile app for people to use, that's similar to other nice
Mm.
mobile apps, that's definitely rich territory for now. But
I think we, oh
sorry, go
yeah,
ahead.
I think we might get two different kinds of assistance for those two scenarios. And I hadn't really thought about the different needs of those two communities before, but it makes total sense. And so the one really need to develop with speed and the other one need to develop with precision. But
Yeah,
I think even for that system programming case, I think we will see a lot of useful AI tools in the area of analysis
yeah,
because those code bases end up being potentially quite complex and quite hard to navigate. And so then you end up with the tools not to like write the code, but just to say, okay, well, where is this happening? And, can you explain this code? And and there, I think they can do interesting things. And we are already seeing the stories where, people try it out for analysis and it comes back and they say, oh, well, no, this is stupid. It got it wrong. And then they look in more detail and they're like, oh, actually, my understanding of the system was wrong. It got it
yeah,
right. At least some of the time.
yeah. I think you and I share something of a background in high performance computing, and an interest in that. And certainly, I wonder whether that's an area where AI I could imagine it kind of helping with the mechanical sympathy, kind of saying, this is a dumb idea because you forgot that that's a block storage device that you're talking to, or something like that. Those sorts of ideas, just reminding us and giving us the information to guide us to better choices when we're solving problems. I could kind of imagine it doing that with the right kind of training, but an interesting problem. The other thing that strikes me and has been a bit of a hobby horse of mine recently is this idea of what the programming looks like for these systems. And one of the problems, it seems to me, is that we are at risk of giving up incrementalism. AIs build code in such a different way. We humans, we kind of write small little changes and we evaluate it after each change and kind of grow the system organically, or at least as far as I can
Mm.
see, the people that are good at it, that's the way that they tend to organize their work. Um, and AIs seem to go bang and give you a whole load of code, and then bang for the same problem and give you a different load of code, unless you kind of turn those down. And even then, new version of AI might generate different code. So how do we, the reproducibility seems interesting to me. So it seems that we still need some kind of formal language is probably the wrong term, but structured way of specifying the problem, even if it's in natural language. And I think that BDD might be a hint
Mm.
at what that looks like. Sort of specify very clearly what the requirement is, and then you can verify that the requirement is met with the test. You have thoughts on that kind of thing in terms of it as a direction?
Yeah, I'm sort of I'm quiet because I'm thinking. Yeah, I think there's like about three different ideas in there that are really interesting. One is I think that BDD one with BDD you do end up sort of having. I always find that there's a slight gap again with BDD between the sort of the promise and then how it actually looks when you implement it. Because the promise is oh, we're going to be able to specify our system in a way that the business can do it. And then when you actually sit down to do it, you find you have a small file that's the sort of the business readable text, and then there's this huge iceberg of how do I translate that business readable text into initializing my system and hooking all of the things together. And it might be that some of that gap could be something that, I mean, I was going to say maybe that would be something that LLMs could help us with, but I'm not sure that that's necessarily any more amenable to LLMs than any other any other coding task. But
Hmm.
it sort of it fits well to the model of how we're using them now, which I guess is why the idea appeals, right? Which is I have this natural language specification and I just want to say that, and then all of the stuff to turn that specification into reality, which in this case is a reality of testing, gets
Yeah.
gets done somewhere else. But I think that idea of incrementalism is really interesting as well, and that might be one of the reasons that the experienced programmers are sometimes uncomfortable with this system, is because it really upends our notion of what good looks like, because we're so
Yeah.
accustomed to, okay, here's how I do it and here's how I can have these tiny little layers of change and I can peel it back in source control, and it, as you say, it just blows all of that out of the water. And I think we don't yet know what good looks like for using this system. Do we have to try and like layer our prompts so that we can do it, the same way as we used to, or is that just a really silly idea, like, trying to make cars look like horse-drawn carriages? We
Yeah.
just need
Yeah.
to change the model.
Yeah. And the other thing it seems to me is that that's kind of been the stumbling block at previous attempts, like model-driven architecture that you mentioned, of trying to raise the level of abstraction, is kind of the reproducibility. What happens when the problem changes a little bit, or what happens when you find something's wrong? I want to go back to it and tweak it a little bit. It's that tweakability, it's the ability to make those small changes that I think that the good professional programmers maintain in terms of their design choices, their ways of working, and so on. And that's the thing that I think we're in danger of discarding. And if we do, that it seems to me that that will severely limit the impact that AI generated code can have. So it's not
Mm.
that I'm against it. I'm for it if it can give the abstraction jump that we're talking about. But I think that's harder to achieve than just throwing an LLM at it and you know hoping that the fact that it can write fizzbuzz means that it can write anything else.
Yeah, and I think there's sort of an open question still about what the optimum unit of delivery is, and that sort of comes back to some of these
Yeah,
questions about and the tweakability and also the verbosity. Is the unit of delivery that I just check my prompts into source control and that everything else is just an implementation detail, or is the unit of delivery that I check the generated code into source control, and then it's up to me to manage this code that maybe
yeah,
isn't how I would have written it, and that kind of thing. But at least then it does have all of the qualities of service that I used to want in terms of like
yeah,
I can change this. I can understand it.
I think that's another interesting point, is that idea of the readability of the code. There have already been several examples where AIs have been communicating with each other, where they've invented new language, that their own languages, to exchange information much more quickly and much more efficiently between themselves. How long is it before we're not going to be able to even read the code that they write? I don't think that's very long at all. I think that's going to come quite quickly if we just let them write the code, and then we don't have the option. So figuring out ways to kind of retain some degree of control, I suppose, is an interesting challenge and an interesting problem. This clip was taken from my podcast, The Engineering Room with Dave Farley, a monthly podcast with some of the brightest minds in software engineering. You can find full episodes on all your favourite podcast platforms, including Spotify, Apple Podcasts and Amazon Music. Your support helps us to bring you these regular episodes, so please leave your positive review on your preferred podcast platform to help us to continue to grow and bring you great guests and their insights. Thank you very much for listening.